Okay, welcome back to the second part of applications. So we're looking here at marginal cost. We just had a look at some ideas around displacement. So the marginal cost of producing two items is the cost function. So there's our cost function. Okay. So what did we establish in our talk originally? A marginal cost as a function of x is in fact the derivative of the cost function. Okay. So let's do it. 3x cubed. 3 comes out the front 3. 9x squared. Do we have to do it one way or the other? No, I don't think so. What about 2x squared becomes 2x? 3x becomes 3. What happens to the 5,000? It's a constant, so the differential is its gone. So that's it. We got there. Find the marginal cost at the production of 200 items. So this is our derivative. Okay, both of these are being used. Either nomenclature will be okay. So we get in 200, whatever it is, function notation, everywhere there's an x, we'll put 200. So 200 squared, use your brackets, 200 plus 3. 200 squared is 400. 4 nines, 3,600, I think. Is it 200 squared? $40,000. 490,000, 360,000. Add a couple of noughts there, buddy. Plus 2 200s is 400. Plus 3. So we get 360, 400, 360,000, 403. That's the cost for 200 items, if that's the correct function. So it's just a way of looking up the cost in a different context, that's all. So very helpful, very helpful. All right, so I just thought I'd do a couple more of these. I'll do these again later, I think, but I'm just going to put them in here now. So y equals cot x. I'll probably do them again in the first week. So we can look at cot in terms of sine and cos. So y equals cot x. Cot is tan upside down. Tan is rise over run, which is y over x. So it's x over y. X is cos. Y is sine. There you go. So y dash is going to be, you guessed it. Okay. So go through and do it. Derivative, sine is cos, derivative cos is minus sine. So then you go and put it out, minus sine x times sine x. So that's u hat v minus cos x v hat u cos x divided by sine x all squared. I'll change that in a second. So we've got, take a minus out, sine squared x plus cos squared x over sine squared x. What's this? One. Wow. And sine squared can be expressed as cosec squared. Wow. All right, so that's fairly straightforward. Just to do those. Sec squared. What's sec squared? Sec's 1 over cos. I always remember it like that. chain rule. So u is equal to cos x, u to the minus 1. So d du, u dx, minus sin x. That one would be minus 1 u minus 2. So we can put them together. And we'll get minus 1u minus times a minus is a plus. So we'll just get sin x u here was, better finish that off, minus 1 over u cos squared x. Okay, so it's sin x over cos squared, minus times minus is a plus. So we get sin x over cos squared x which can be written as sin x sec squared x. Okay. Cosec x is 1 over sine. Okay, 1 over sine x, which is sine to the minus 1. So doing the chain rule again. Okay, so the chain rule again will lead you to the derivative. Okay. So finding their derivatives. Pretty good. You'll need those, I think, at some point. Alright, any more? Yeah. A couple of interesting ones. So what's this product? So it's a UV product. Now the differential of 1 over x squared, the differential of the ln of x is 1 over x. So bring the 2 out the front. So we get 2 ln of x. There's a use of our, and cos 3 of x, that's a chain rule. So to get these out, it's a little bit of work. Okay. So the differential of the ln of x is 1 over x, so that'll be 2 over x. U. So u dash will be 2 over x. And this one v dash will be minus, because differential cos is minus sine. But there's a 3, isn't there? 3 sine. I told you not to do shortcuts. So we've got u dash v plus v dash. Got 2 over x cos 3x plus minus 3 sine 3x times 2 ln of x. So all of that equals 2 cos 3x minus 3 2 is 6 so lots of algebra. The actual differentials didn't take long at all. Okay, calculus is not the problem. So here we've got a more complicated product rule and a chain. Okay, more complicated one. So U, B, U's easy enough. Differential sign is cos, so the differential cos is minus sine. So that's easy enough. One goes. E to the 2x. So V is equal to, so we'll let M equal 2x and V can be written as E to the U. Oh, wait a minute, that's the one we love. If E to U is equal to, and dm dx. dm dx is 2. E to the U is E to the U. Doesn't change. Oh, that's why we love it so much. Put them together and you get 2e to the u. So it'll be 2e to the 2x. Oh, so the calculus doesn't take long at all. But the differential will be minus sine x times e to the 2x v minus sine x times cos x plus 1. So the actual substitution now is an interesting one. That's all it is though. Just interesting. Okay, so we can tidy this up, bring the e to the 2x, bring it over that side actually, because this is a positive now, isn't it? Minus times minus is a plus. So this is sine x cos x plus 1 plus sine x e to the 2x. So you can check that with technology, that's no problem. Okay, no problem at all. So let's have a look at these. Yeah, we've got a few more to do. Ln of x, 1 over x. Shouldn't be too much drama. Now, they're inside this bracket, aren't they? And they're as a product. So as a log law, we can take ln AB and make it into ln A plus ln B. So there's the log law at work. So it'll be the ln of A, which is x plus 1, plus the ln of 2x minus 3. So that's fairly straightforward. Okay. So it's a U and V, isn't it? Product. Now it's fairly straightforward now. We don't need to do a product rule. Okay. The differential of inside is 1, the differential of inside is 2. So the shortcut would be we would just multiply them that way. And the differential of ln is 1 over. So we can do let m equal x plus 1. Let n 2x minus 3 dm of the ln of m. What does that equal? Then this one here, the dn of the ln of n. What does that equal? Likewise, we need the m dx. And over here we need the n dx. So there's a few to work out. The ln of m is 1 over m. That's 1. Ln of m is 1 over n, and that is 2. So we can put them together. These are our chains here, this pair and this pair. So if we put them together, we will get 1 over m, which is 1 over x plus 1, times 1, which is just that. And then we'll have a plus sign, and 1 over n, but it won't be 1, it'll be 2. 2 over 2x minus 3. And you can't cancel the 2 because the algebraic plus or minus. Okay? So that's your final derivative. So the chain rule. Can you see how important the chain rule is? The chain rule, the chain rule, the chain rule. I can't emphasize it enough for you. Okay? Let m equal 4x. For this one here, this is a product, by the way. So we'll just deal with the other bits first. Let n equal 4x. So they're different. So we're going to ddm the ln of m. We're also going to have dm dx. So that's the chain. They're a chain together. ddx. We're also going to have ddn of e to the n. That's the other one. And we're also going to have dn dx. So that's the second chain for the second term. So we end up with, what's the differential of the ln of m? It's 1 over m. And this one's 4. So it's 4 over m. So u dash is equal to 4 over 4x, which is 1 over x. The ddn of e to the n, that's the one we love. It's just itself. This one is 4. So putting them together, we get b dash is equal to 4 e to the 4x. There are patterns, but nevertheless. So y dash is a product in u and b. So we're going to have b dash times u for e to the 4x times the ln of 4x plus u dash b. So u dash was 1 over x times 4e. Okay, so that's our final way out there, 4e to the 4x over x. And there's no cancelling, they're just in those forms, they just remain in those forms. Okay, just a bit more work in terms of our applications. Alright, I'm going to stop the video here and just write these out as quotients because as I said to you, I want to emphasize your work with products and chains. I'm more interested in you doing products and change. Okay, and the quotients will de-emphasize. Alright, that'll do the video. Thanks.